Hi guys, welcome back to my YouTube channel. Today I would like us to look at vectors, precisely vector geometry. Talking about vector geometry, we have a figure here. This question will be tackling this question, this trapezium. Now, from this shape, we have Q and S being the midpoint. Q is the midpoint of PM, of the line segment PM. S is the midpoint of LN. Take note. And we have been given P to L, L to M. In fact, one thing to note in vector geometry is make sure you use only the path that you know, like the path having arrows. You have this path here that have arrows. Okay, you follow those paths. Now, equally, note that if you go against any of these arrows, the sign become negative. Like this is PL. PL is A, means LP. P to L is A, means LP will instead be negative A. Okay. Alright. That said, we are asked from the diagram to find PM, PQ, LN, and LS in terms of A and B. In terms of A and B. So how then do you obtain our PM? From the diagram, how do you obtain our PM? P to M means you must start at P. This is our P. P. We start here. Okay. Go to M. You cannot follow this path because there's no arrow here there indicating, and there's no value there, no letter there indicating that road. So we have to take with PL plus LM. And PL is A, LM is B, so A plus B. Now to demonstrate clearly only on that diagram, permit me squeeze it here so that the diagram will be showing. We have PQ, okay, PQ. PQ means P to Q. Now, PQ, they say Q is the midpoint of PM. Take note. If Q is the midpoint of PM, what does that imply? It means PQ has gone halfway from P to M. Q is the midpoint, means half of this line is at. So PQ is half of PM. Half P to M. And what is our PM? A plus B. So it's half A plus B. Okay. Now, equally, we are asked to obtain LM. LM from our diagram, LN. LN means from L to N. And if you look at our diagram, L to N, you have L, start at L. Take note, when I say LN, must start at L to M, then plus M to N. If you look, L to M is B, M to N. We know that N to M is Ka, means M to N against the arrow is negative Ka. So our answer is B plus LM plus MN, okay, which is B minus Ka, as I indicated above. Now we equally have LS. Let's go back to our diagram. LS, our vector diagram. LS. Okay. Now LS is the midpoint of LN. What does that mean? It means from L to S, it will be half of all of this line. From L here to S here is half of L to N. So LS is half LN. Okay. So LS is half LN. And what is LN? LN has been obtained already as B minus K. So it's half bracket B minus KA. That is our L. So we see we've obtained PM, we've obtained PQ, we've obtained LN, LS. Now, the last part of the question is that was to show that QS, that's from Q to S, is 1 minus K over 2, all that A. QS is, okay, QS. Let's go back to our QS. Let's look at the road that we're going to take. What is the possible road that we're going to take? QS is from, means you have to start from Q to go to S. Either we take Q, M, L, L to S, or we can take Q, P, okay, Q, we are going from Q to S, right? We can equally say Q to M, alright, plus M to L, plus L now to S. Let's look. This is the road that we are taking. Q, M, okay, M, L, then L, S. Take note. Alright. So we first of all write our QS is QM plus ML plus LS. And always see how these vectors are written. QS, Q to M, this is here, QM. You see, and after QM you have ML. You see the way they are linked. This part is linked using Chancellor's relation. So our QM, from our diagram, we have that our QM is half A plus B, right? Which we obtain. Then our ML is negative B. Our LS that we have here is half B minus KA. Is our LS. Most of the things we already have them. Our QM is it here. Our QM is half of PM. We have half A plus B because PM is A plus. Our ML, you see we are going against that arrow. That's why we have negative. All right. Now with this, we have our LCM is 2. So we have 2. 2 here, 2 divided by 2, 1. So we have here A plus B minus 2B. Okay. 2 divided by 2 here, 1. Then A plus B minus KA. We simplify. We have here A, B minus 2B is negative B. Negative B plus B, 0. So we are left with K minus, we are left here with K minus KA over 2, which is equal to, gives us the required result, 1 minus K over 2, all that A, because here we are able to factorize A minus KA, we are able to factorize A. Okay, all right. It's how we handle questions on vector geometry. Okay, continue with the example. Now this is a second example. Make sure we master. This is another vector diagram. Okay, OPQ. All right. OP from O to P is P bar, from O to Q bar. This is a GCE question, 2023. Now we equally have this condition. PM is to MQ is 2 is to 1. from this, this express in terms, you have to express in terms of P and Q the vectors. You have to express the vectors P, Q, and PQ and PM. From our diagram here, looking at our diagram, what is PQ? PQ, we start at P. So it's P, you see P to O, and O to Q. So it's PO plus OQ. And what is our PO? We're going against this arrow. So our PO negative P. What is our OQ? Is pure. So we are done. That's our answer. Now the next question is PM. PM. Take note that this line, line PQ, has been shared in the ratio PM is to MQ. And when you say 2 is to 1, okay, it means anything in this line, on this line, to share it, you must look for the sum of that ratio. And sum of ratio there is 2 plus 1, which is 3. Which means PM is 2/3 of this line segment PQ. And MQ is 1/3. Because 2, they say PM has 2 is to 1. Alright? You see that all of this line is 3. So what then will be our answer to PM? Our answer to PM is simply 2/3 of PQ. And what is our PQ? Negative P plus Q. And we are done. And we are done. Can you decide to follow instead of saying P, we also obtain PM. Some can take PM is P to O, O to Q, Q to M. Very long. I advise you to use the aspect of the sum of ratio, right? Sharing in that ratio, 2 is to 1. You must look for sum. When you have vector diagrams that have to do with ratio, you obtain the first thing is the sum of ratio, so as to be able to share that line in that ratio. Okay, thank you for watching. Thank you for following. Please like, subscribe, share. See you in subsequent videos. Have a great day.